This is Algebra 2, Unit 5, Lesson 3, the rest of the notes on summation notation. Okay, so for summation notation, what we have to be able to do is express using sigma notation. So we left off in exercise 4, express each sum using sigma notation. Use I as your index variable. First, consider any patterns you notice amongst the terms involved in the sum, then put in the formula and sum. Okay, so we have 9 plus 16 plus 25 plus ... up to plus 100. Okay, so do we notice any pattern about these numbers? Well, isn't this one actually the perfect squares? Yeah, this would be 3 squared. This would be 4 squared plus 5 squared plus ... up to plus 10 squared. Okay, so when I do my summation here, I am doing whatever the index is squared, all right, to get my sum. So what index do I start, or what number do I start at? I start at 3. So I is going to equal 3, goes down to here. And when do I stop? Well, I stop when I is 10. So this is the summation of from starting at 3 and going to 10 of I squared. Now this isn't the only way to do this. There's other ways you could do it, but this is just one of the ways. Okay, let's take a look at the next one. All right, we have -6, -3, 0, 3, and then ... to 15. What's happening every time we do this? Going from here to here, here to here, here to here. What do we notice about those numbers? We are adding 3. Okay, so that makes this an arithmetic series. So our arithmetic sequence. I'm adding the arithmetic sequence starting from -6 until I get to the term of 15. So I need to know what the formula is for that arithmetic sequence. All right, so remember the general formula for arithmetic sequence is A of n equals A1, the first term, plus n minus 1 times d, which is the common difference. Okay, so let's see what we know for this. So our formula for this, our first term of our sequence is going to be -6. So if I'm going to write my formula, -6 plus, all right, well I know my common difference d is going to be 3, so that's going to go over here. And then this is going to be n minus 1 because whatever term this is going to add 3 one time less than that. All right, so in general, when I solve this, A of n is going to equal -6 plus 3n minus 3. So when I combine this gives me 3n minus 9. So that is my sequence, or my formula for my sequence. Now, if I want to sum those, here's my summation. That's going to be my formula. I'm just going to use I instead of n. And then I've got to figure out what term of the sequence I'm going to start with. All right, well, if I want the first term to be 6, that would have to be I equals 1, or -6, excuse me. 3 times -1, or what was it? Yeah. Okay, 3 times 1 is 3 minus 9 is -6, and that gives me the first term. Okay, now what I need to figure out is how many terms will I get to be 15. Okay, so if I take my formula, 3n minus 9 equals 15, that will tell me what term number 15 is. So if I add 9, I get 3n is equal to 24, so that means n is equal to 8. So this is actually the 8th term of the sequence based on using this formula. So I'm going to go start at the first term, I'm going to go to the 8th term to do 3i minus 9. Okay, let's look at letter C. All right, do you notice a pattern for this? All right, 1 over 25, 1 over 5, 1, 5, 625. All right, do we notice anything about those numbers? Yeah, I can write these as powers of 5. All right, 1 over 25 is 1 over 5 squared, which we can write as 5 to the -2. 1 over 5 is 1 over 5 to the first, which we can write as 5 to the -1. Okay, 1, I can write it as a base of 5, it's going to be 5 to the 0. And then 5 to the 1. And then plus ... and it's 5 to some power is 625. All right, so if I do 625, I do know it's 5 to the 4th. is going to be 625. So that's my pattern that I have for my sequence. All right, so what kind of sequence is this? Well, we're going to be summing powers of 5. So it's going to be 5 to whatever exponent I decide to use. All right, so what is the first exponent in my sequence? Well, it would be -2. So my I here is going to be -2. And then the last term of my sequence is going to be 4. So the last one I'm going to plug in is going to be 4. So this is going to be 5 raised to the I power from -2 to 4. And then if you sum that up, that's what you get. Okay, so which of the following represents the sum of 3 plus 6 plus 12 plus 24 plus 48? All right, what do we notice about these numbers? Well, what's happening every time as we go from here across? We're multiplying by 2, aren't we? So what kind of sequence is this? This is a geometric sequence. Yeah, so the geometric sequence formula is A of n equals A1 times R to the n minus 1. That's my general sequence formula. So what I need to figure out is which one of these formulas will work for this. Well, let me see if this is going to work for here. All right, my first term is going to be 3. All right, my multiplier is going to be 2 to the n minus 1. All right. Okay, now what I need to figure out, though, is which one of these is going to work for this. So I think it's probably going to be this one, but let's make sure that this is the one it's going to be. All right, if I plug in 0 into this formula, that would give me 3 times 2 to the 0, which is equal to 2 to the 0 is 1, which is equal to 3, which is the first term of the sequence. All right, the second term of the sequence would be 3 times 2 to the first. 2 to the first is 2 times 3 is 6. That's the second term of the sequence. And then to the second would be 3 times 4 is 12. And then to the fourth one, let me see. And then I want, as I keep going up, it's going to give me to the fourth, and that's the one I want, I believe. Okay, then I want 3 times 2 to the third, which would be 8 times 3 is 24. And then 3 times 2 to the fourth, because that'd be the fourth one that we want, would be to the fourth is 16 times 3 is 48. So that matches all the terms of the sequence, and then I can add them together. So you have to make sure the one that it has fits the terms. All right, now notice on this is a to the n is n minus 1. This one is using 0. So that's why this one is 0 and this one is 0. So you could also write this in a different way. We're using the sequence formula to get a general idea, but we want to see if this pattern would fit. Okay, so let's look at the last exercise. Some sums are more interesting than others. Determine the value of the summation here. Show your reasoning. This is known as the telescoping series or sum. Okay, so let's set up our sum that we have here. My first term means I plug in 1 for I, is going to be 1 over 1 minus 1 over 1 plus 1. All right, that gives me 1 minus a half. All right, my second term, 1 over 2 minus 1 over 2 plus 1. And that would give me 1/2 minus a third. Okay, my third term, all right, I plug in I equals 3 minus 1 over 3 plus 1 is going to be 1/3 minus 1/4. All right, and then plus dot, dot, dot. The last term I want to be is the 99th term of the sequence. Okay, so this is going to be 1 over 99 minus 1 over 99 plus 1, which is 1 over 99 minus 1 over 100. Okay, now look at your terms of your sequence. What do you notice if you drop the parentheses here? 1 minus a half plus a half minus a third plus a third minus a fourth plus dot, dot, dot plus 1 over 99 minus 100. Okay, what do you notice about these terms right here? they're going to cancel out to be 0. So what term is going to be left? We assume the next term here is going to be 1/4. All right, we're left with 1. And then the last term, this will cancel out because this last term here would be 1/99. And those would cancel out to be 0, leaving 1 minus 100. So your answer actually is going to be, this is 100/100 minus 1/100, oops, 100, not 1,000, is 99/100. Okay, so that is summation notation. What I really want you to be able to do is to read and understand how the notation is set up and how to use it. Okay, the last thing I want to show you is how to do summation using the calculator or Desmos. I showed you how to use it on the calculator, but let's show you how to use it on Desmos. If you go down to your keypad right down here, and you go over to the functions thing, and you go over to miscellaneous, you have trig, stats, distributions, and miscellaneous. If you look at the miscellaneous one, the summation is there. It's this one right here. Okay, the only difference is instead of using I, it uses N. When you do it on your calculator, you use X. All right, so if you wanted to do, for example, one of the ones on the notes, like the first one on the notes was from I equals 3. So you just put N equals 3, and then you click up to here, and this would be 3 to 5. And then out front, when you click there, it would be 2, and you would have to use N, I believe it is, 2N, because the N is here. All right, and you can see it's going to be 24. Okay, so that is using Desmos for that if you're just using a summation thing. All right, remember for the calculator, if you're using summation, it's alpha, window, and then you want number 2, and you just use X for your values. If I just did the same one we just did a minute ago, you would just say X equals, or you can use any letter you want, 3, and then up here would be 5, and then in the parentheses would be 2x. So whatever index you use here, you should use in your parentheses here. And you can see we will get the same answer. So yes, you can do it on your calculator, but you should also understand where the summation values are coming from. Okay, that's it. You can start your homework.